You are welcome to today's mathematics class. I am Mr. DB EO, and we will continue with the topic we started last week, which is numbers in base 2. Remember last week we talked about number in base 2, which is binary number, and we learned how to convert number in base 2 to number in base 10, and also how to change number in base 10 to number in base 2. And then today we will continue in this line, and let's look at the lesson we have for today. Lesson objectives. By the end of the lesson, students should be able to convert from one base to another base. That is, you can convert from base 3 to base 4 and many more. 2. Perform basic operations with binary numeral. That is, addition, subtraction, and multiplication of binary numbers. And let's move to the lesson in detail. So the first one we have is converting from one base to another. There are 2 steps required for this to be done. So the steps involved in changing from one base to another are: 1. First, convert to base 10. That is, you convert the given base to base 10, then convert to the required base. Then now convert the number you have converted to base 10 to the required base. Let's look at these 2 examples. Example 1. Change the following to the required base. 1. 23 base 5 to base 8. 2. 156 base 8 to base 5. And let's go to the next slide to see the solution. So number 1, 23 base 5 to base 6. So step 1, convert 23 base 5 to base 10. That's the first thing you will do. You first convert the given base to base 10 before you now convert it to the required base. So we have our 23 base 5. Then remember our numbering, that is leftward. So we have 2 times 5. Remember the base is 5 raised to power 1 plus 3 times 5 raised to power 0. So we have 2 times 5. That is 5 raised to power 1 is 5 plus 3 times anything raised to power 0 is 1. So we have our 10 plus 3 equals to 13 base 10. You notice that we have converted our 23 base 5 to base 10. And the answer we got is 13 base 10. So the next thing to do is now to convert the 13 base 10 to the required base, which is base 6. So we are going to use our long division to do that. So we have 13 divided by 6, that will give us 2, remainder 1. And 2 divided by 6 will give us 0, remainder 2. Finally, the answer we got is 23 base 5 equals to 21 base 6. So that is how we will convert to base 6. Now let's move to the next slide for the next example. 156 base 8. Step 1. Convert 156 base 8 to base 10. So we have our 156 base 8. Then remember our numbering 210. And the base is 8. So we have 1 times 8 raised to power 2 plus 5 times 8 raised to power 1 plus 6 times 8 raised to power 0. Our 8 squared is 8 times 8, which is 64. So we have 1 times 64 plus 5 times 8 raised to power 1 is 8 plus 6 times 8 raised to power 0 is 1. So we have 64 plus 40. That will give us 104 plus 6. That will give us 110. That's 110 base 10. Now, the second step is for us to convert 110 base 10 to base 5. We will make use of the long division. So we have 110 divided by 5 give us 22, remainder 0. 22 divided by 5 give us 4, remainder 2. And 4 divided by 5 give us 0, remainder 4. Now, our 156 base 8 equals to 420 base 5. We can go over the example again for better understanding. Now let's move to the next objective of today's lesson, which is basic operation in binary number. The basic operation in binary number are addition, subtraction, and multiplication. We also have division, but that is higher for your class. So when you get to SS class or GSS3, you'll be taught how to perform division operation in binary number. Now, in addition, you have to note this thing. They are very important. You have to note this. In addition, 1 plus 1 equals to 1, 0. And 1 plus 1 plus 1 equals to 1, 1. How did we come about this? Remember that in base 10, 1 plus 1 equals to 2. And you have to perform the division by saying 2 divided by 2, you have 1 remainder 0. And 1 divided by 2 will give you 0 remainder 1. And when you write it the normal way, it will be 1, 0. Likewise, when you have 1 plus 1 plus 1, that will give us 3 in base 10 normally. And we have to convert it to base 2. That will be 3 divided by 2 will give us 1 remainder 1. And 1 divided by 2 will give us 0 remainder 1. So when we write it the normal way, we have 1, 1. And in subtraction, when you borrow 1, it turns to 2 because of the base. Remember that the base you are dealing with is base 2. So when you borrow 1 from the other number, it will turn to 2 so that you can easily subtract it and get your final answer. The multiplication remains the normal multiplication. You only apply the addition rule when you are adding the numbers together. So example, simplify the following. 101 plus 111, 2, 1110 minus 101, C, which is the third one, 101 times 11. So let's move to the next slide to see the solution to these examples. So the solution, we have 101 in base 2 plus 111. So let's start from the right to the left. 1 plus 1. Remember I told you that in binary number, 1 plus 1 is 1, 0. So we are going to write 0 and carry 1. So we have the 0. Then the number in the middle, which is 0 plus 1, which is 1. Remember we carried 1. We are going to add the 1 to it. So that will also give us 1, 0. So we add 0 and carry 1. Then the last number by the left. So we have 1 plus 1. That is 2 plus the 1 we carried. So that will give us 1 plus 1 plus 1, which is equals to 1, 1 in binary number. So we are going to write 1 and carry the remaining 1. So we can now write the remaining 1 after. So it means our 101 plus 111 in binary number equals to 1100. So let's move to example 2. In example 2, you have 1110 minus 101. Now, from the right hand side, we have 0 minus 1. That will give us, that's impossible. So we have to borrow 1 from the number that follows. So when we borrow 1, it will turn to 2 because the number is in base 2. So we can now say 2 minus 1, that will give us 1. Remember we have borrowed 1, the other one standing beside the 0. So when we have, so that will not be 0 minus 0, that will mean 0. 1 minus 1 is 0. Then 1 minus nothing, that is also what? 0. That is 1, sorry. That is 1. So our 1110 minus 101 in binary number is equals to 1001. Now, example 3, where we have multiplication. So we have 101 multiplied by 1. We do the multiplication as we always do it with numbers. So we have 1 times 1 gives us 1. 1 times 0 gives us 0, and 1 times 1 gives us 1. Then we have 1, the second one, 1 times 1 gives us 1. 1 times 0 gives us 0, and 1 times 1 gives us 1. Then we will add them together. So we have 1 plus nothing, that is 1. 0 plus 1, that is 1. 1 plus 0, that is 1. And the remaining, the last part, which is 1. This means our 101 times 11 in binary numeral is 1111. For better understanding, you can go over the lesson again. Thank you for listening, and I will drop your assignment in the class. Please make sure you do the assignment and submit. Have a blessed day. We shall meet again next week. Goodbye.